Let's start with sonication. Sonication is perhaps the most extensively used method for the preparation of small unilaminar vesicles. In this method, multilaminar vesicles are sonicated either with the bath type sonicator or with the probe sonicator under a passive atmosphere. There are certain disadvantages of this method. The main disadvantages are that very low internal volume or encapsulation efficacy is attained, and there is a possibility of degradation of phospholipids and compounds that are to be encapsulated. And the disadvantage is the elimination of large molecules during the drug loading, and metal pollution from probe tip. If you are using a probe sonicator, then the metal pollution can occur, and the presence of multilaminar vesicles along with small unilaminar vesicles coexist. If sonication is being carried out either by probe sonication or bath sonication, there are chances that multilaminar vesicles will actually coexist along with the small unilaminar vesicles in a fewer concentration, but their presence will actually lead to disadvantages. There are two sonication techniques which are used. Probe sonication. In probe sonication, the tip of the sonicator is directly engrossed into the liposome dispersion. The energy input into the lipid dispersion is very high in this method. Coupling of the energy at the tip results in local hotness. Therefore, the vessel must be engrossed into a water or ice bath. What is done over here is that when a liposomal dispersion is actually treated with the tip of the sonicator, that dispersion in whatever vessel it is, that vessel is dipped in a water or ice bath in order to maintain its temperature, because the probe sonicator would increase the inside temperature or local hotness. Through this sonication up to 1 hour, more than 5% of the lipids can be de-esterified, and with probe sonicator, titanium will slug off and pollute the solution. That probe sonicator is actually made of this titanium, and titanium will actually slug off because the duration of sonication is up to 1 hour, and that duration can lead to contamination of metal into that liposomal dispersion. The other method is bath sonication. In bath sonication, liposome dispersion in a cylinder is placed into a bath sonicator. The temperature is controlled of the lipid dispersion. The temperature controlling power and by this method is much easier than the probe sonication method. In this material being sonicated can be protected in sterile vessel, dissimilar to the probe units, or under an inert atmosphere. Second type of method which is utilized over here is French pressure cell extrusion method. In French pressure cell extrusion, the extrusion of multilaminar vesicles through small orifices is being carried out. Important feature of the French press vesicle method is that the proteins do not seem to be significantly proteinous during the procedure as they are in sonication. French press vesicle appears to recall entrapped solutes significantly longer than small unilaminar vesicles produced by sonication or detergent removal. The method involves the handling of unstable materials as well. The method has several advantages over sonication method. The resulting liposomes are rather larger than sonicated small unilaminar vesicles. The drawback of this method is that the high temperature is difficult to attain and working volumes are comparatively small as compared to the probe and bath sonication methods. Freeze-thawed liposomes. Freeze-thaw method is used for the production of liposomes. The small unilaminar vesicles are actually rapidly frozen and thawed slowly. In this freezing and thawing process, the short-lived sonication disperses aggregated materials to large unilaminar vesicles. These creation of unilaminar vesicles as a result of the fusion of small unilaminar vesicles throughout the process of freezing and thawing is possible. This type of synthesis is strongly inhibited by increasing the phospholipid concentration and by increasing the ionic strength of the medium. The encapsulation efficacy is from 20% to 30%. Other method is or type 2 method is solvent dispersion method. This solvent dispersion method includes three other types of methods. One is called as ether injection method or solvent vaporization method. Second one is called as ethanol injection method, and third is called as reverse phase evaporation.